Welcome to Ask and Learn.
To calculate the empirical formula of urea, we need to carry out a calculation that was performed in a previous chapter where we assume we have 100 grams of the compound and then the percentages correspond to the mass in grams of each element. So if it's 20.1% carbon, then we have 20.1 grams of carbon, which we can convert to moles of carbon by dividing by the molar mass of carbon. We do that with each element: hydrogen at 6.7%, nitrogen at 46.5%, and then the balance being oxygen. The balance is 26.7%, so a 100 gram sample has 26.7 grams of oxygen. Converting all of these to moles by dividing by the molar mass, we get these mole values. In an attempt to get whole mole values, we'll divide by the smallest of the four of them, giving us 1 mole of carbon for every 1 mole of oxygen, for every 2 moles of nitrogen, and 4 moles of hydrogen. So the empirical formula is CH4N2O. Now from the osmotic pressure, we can determine the molarity by dividing R and T into the osmotic pressure, and we get a molarity of 8.34 times 10 to the negative 2. So that means if we have 8.34 times 10 to the negative 2 moles in a liter, if it was prepared as 5 grams in a liter, then we have 5 grams of urea for every 8.34 times 10 to the negative 2 moles of urea. Dividing these two numbers gives us grams per mole, which are the units of molar mass, and we get 50.94 grams per mole, which is essentially the same as the molar mass of the empirical formula. So the empirical formula is also the molecular formula.